Unfortunately, we don't have HDMI output. Then we are going to the lecture today, and we talked about lecture, but next Tuesday and exam.
Sorry?
Next week we will have exam, right? Tuesday, right?
Not next Tuesday. Next.
Perfect. Then we will continue on this indexes next week, and we'll talk about the SQL Server and what we are seeing over here, how it is reflected, and SQL Server Tuning Advisor can work for us. So the quiz was very simple, but just one simple word. I had one more quiz in my mind. Bennett knows that I wanted to post another quiz. I realized that Canvas is very helpful. Yesterday night I was exploring Canvas and I realized that this is a very helpful electronic e-learning system. From now on, you will have frequently quizzes based on the schemas we are talking in the class. For example, we talked about the schemas of employees, so you know what tables are, and if you know what tables are, and then you shouldn't go and grab the department number from the table department number. You have to do the join and give the development as a part of the query. Anyways, this is an experience for you. We have lots of quizzes like next coming, so if you lost the quiz, don't worry about this. You will have time to recover the grades, but we will have quizzes, and I know that the quiz was very simple because it is just one query. You are not supposed to write the query. You are just put some specific condition regarding the join. So in order to facilitate the answering the queries, I will creating the quizzes. I will put this fill in the blank queries, and we will ask some specific questions. Plus, we may have multiple choices queries that we're asking about different types of joins, different types of stuff we are working on. So I will post this on the Canvas about the projects. So far, you learned how to design a database and implement the tables, right? So for the first part of the project, okay, you need to give me two artifacts. One is the complete description of the entities, plus ERD diagrams, and also the table, the schema of the tables you are designing. And the second part should be the SQL file, which contains the SQL script for creating the tables. I don't care if you create this script through automatic generation of Oracle or SQL Server, because they are enabling you to design tables in a visual format, and then you can generate SQL scripts out of it. But I just need to get a SQL file and see if the SQL file is executable or not. So and also it is required that you do your project on Oracle, because because all of these DBMS systems for properties of attributes in the tables, they are using some specific terms and keywords that is not standard in the SQL. As a grader, I'm using Oracle to check if your database is correct or not. For the naming of the database, okay, in order to avoid any redundant naming, I would like to remind you that I will give you some rules how to name your database regarding to the name of the group people. Probably you need to put a specific table number or put a general name, and I can create a database on my system and just immediately drop it to check if it is working or not. Okay. And regarding to the homework, some people send. Bennett told me that In order to facilitate submitting the homework, you need to submit it electronically, okay? Either you are in distance learning class or in regular class we have, you are supposed to submit it, but some people, for each page of the homework, they took a picture and with these applications on the cell phone created a separated PDF file. And then they submitted several PDF files in order to submit their homework. And when I want to check the homeworks, I have to check a lot of files. And sometimes if your file suddenly have the same name with your colleague's files, then definitely you will miss the grade and you will miss your mark. So because Canvas let me download the whole submissions and then I can grade it. If you have one single file in your name with the PDF, that's okay. But if you have several files with some names that is not obvious whose homework it is, then it will be very difficult for me to find out, and you may lose some marks because I may confuse with other people's submissions. Whoever submitted the homework after midnight Tuesday, okay, after midnight Tuesday to Wednesday, I will not accept the homework. I was asked to be more rigid and more tough on the students. I realized that the class needs to be more serious. So whoever submitted the homework after exactly the time, I will not accept the homework, okay? Even 1 minute or 2 minutes. Before the time, if you have difficulties sign, if you have difficulties to submit it through Canvas, it's okay to email me and I will accept. There was a gentleman named Vijay. You submitted, you sent me the email before the midnight, one email, right?
Yeah.
And I accept his submission, but for the rest of the people sent me the email 4 a.m. on Wednesday, 3 a.m. on Wednesday, 12 a.m. in the Wednesday, I'm not gonna accept it. Okay, so this is the rules. Okay, we will have more homeworks from now on, and I will make the homeworks easier for you. I realize that the homework is a bit too much. Had different types. Fortunately, we will not have design questions anymore, but we will have SQL questions from now on. And when we get to object-oriented databases, we will have object ORM questions as well, and Python questions. Okay, any question? No questions? How many people successfully submitted their homework, their quiz in this class? So, a lot of successful submissions of the quiz. Perfect.
You get the mark.
So for the next step, make sure that you bring your computer to the class. I'm not sure if I can ask you, Professor Manu told me that I can ask you to bring your computer essentially to the class, and if I can do that, then I will get quizzes in the class and it will be easier for you because I will be here, and if you have any questions or doubt, I can immediately answer. I know that the quiz, take-home quiz is a bit more confusing because students are taking the quiz at home probably, and also you may get consultations from your friends, which is, I'm sure that you are not doing it, but some of the students, some of the not good students are doing that. So it will be better for me and for you to have the quiz in the class. So from now on, it is, if it is possible for you, at least bring your computer, and if you have SQL Server, Oracle, and MySQL installed on your computer, then whatever we are teaching, we are talking here, you can explore by yourself. Okay, so we will talk about the physical organization of, databases and indexing. The second project we will have will be implementation of B+3 indexing system. So this section and next section, please pay attention if you want to submit your project successfully. And the implementation language should be Java. Okay. I know that this is a file structure project, and so many people may like that. We had this project when we were undergraduate. I know that, but it was the policy of the school. I have to cover this part, and I have to ask this project to do. So please make it serious.
You can use any language or only Java?
What?
Can we use
Only
.NET?
Java?
Yes, because C++, I can find thousands of the implementation on the internet.
Can we use .NET?
No,
Python.
but
Python.
let's say Python is okay, but Python is a scripting language, you know. Who is implementing some data structure in Python? You know? It's okay, but no, Python is not okay. Because it's not an appropriate language to do this task, right?
Yeah, Python.
Okay, and then I'll get this project in one of the project delivery sections, probably 30 minutes after your class or before your class. And for distance learning people, they have to come over and just deliver their homework, their project. If they are not available, they can chat online. Listen, if you are implementing the indexing, I am checking the code, and please do not use hashing or some tricks that you write the function and override the function later on. The index is not working. And I was also a student. I know all of these tricks. And be 100% sure that I cannot be trapped on such tricks. So, okay, today we will talk about disks. What is the feature of the disk? Disks are the main, although these days SSD devices are used, or flash memory structures are used to store volatile information. Still, databases are relying on disks, and since many of the databases are already located and already stored in the disks, then we have to learn what disks are and how they are organized. So, disks are usually used for storing large quantity of data, and the price of the storing is very cheap. So that's why we are using disks. There is a research topic going on, which is in-memory databases, and in-memory databases are those databases are not used and are not stored on the disk. You have this concept, you can have databases completely stored on memory, but there are a few problems. The first problem is that every time you want to load the database, you have to bootstrap the whole data to the memory, and then when you want to shut down the database, you have to write down everything to the memory, to the non-volatile storage. But if you have some problems with your operating system, like for example, power outage, the data will be gone, and then this is not very good for integrity of database. Disks are providing then non-volatile storing, and also another feature of the disks are that they are very slow. So since they are very slow, from now on for all of the algorithms, we are trying to minimize the number of disk accesses by the DBMS systems. And the performance of the database DBMS is largely a function of the number of disks, disk I/O operations, and database tuning devices, usually database tuning toolkits, usually try to help you to find the best way to store information on the disk. Next Tuesday we'll talk about data tuning toolkit for the SQL server, and you will see how MySQL doesn't have very advanced tuning stuff. The MySQL just let you decide about the indexes, but it doesn't let you decide about how data is stored in the system, how many mirrors you can have in the system. But modern database management systems like Oracle and SQL Server enables you to decide about all of these factors and parameters. The disk has a structure of like this. So I'm sure all of you know about this. The disk has some platter, and on the platter, since there's a spindle and all of the platters are rotating around this spindle, then we can assume some circles on each disk, which is called track, and instead of tracks parallel based on the parallelism of the disks are called cylinder, and each track is divided to some sectors, and there is a header and there is an R assembly which is moving the header toward center or outside of the circles. Okay. Everyone knows this. Okay, so the number of sectors, is it different from inner circles to outer circles or not? The number of sectors?
No.
No. Why?
They are same.
Why they are same? Because the rotation speed is not changed. Therefore, they cannot. Although you have larger space and you can put more information on the outer circles, but since the changing the speed of the spindle is very difficult, and the spindles are usually rotated by stepper motors, then they cannot change the density of they cannot keep the density of the information on the different circles and tracks constant. So then another important concept is pages and blocks. So you all know about pages and blocks from the operating system course. Basically, data files are decomposed into pages, and each page is a fixed size of the amount of the information from the file, and basically blocks and pages are the units of the exchanging information between processing units and disk, or main memory and disk. So these are divided into page size blocks of the storage, basically, and page can be stored into any block. So you cannot have any assumption which block is containing which page based on the corresponding file of the page, or based on the database pages. So for reading an item from the disk, what you are doing is you have to retrieve the appropriate page, and then go to you have to recognize and locate the appropriate page and read the page to the buffer. And if the request is sent by an application, you have to send the buffer to the application, or you have to filter some part of the buffer and send the requested information to the application. For the write request, you need to first read the containing page to the buffer if it is not already in the buffer, and then change the item, and eventually write the page to the disk. So why eventually?
Because it is scheduled.
Why?
Because it is scheduled.
No. Why eventually? Not why? You're not sure every time that you have to write it back.
Speed of the speeds are different, so you
No.
prefer.
No, listen. You get an update query. You read the block. You read the page from the disk. You find the record. It should be updated. You update the record, and then you either decide to write it back, or eventually you are not writing it back. Why? Why this eventually happens?
To roll back like atoms.
No. Suppose that the update query asks to find the record for Baseda and change the name to Reza. Okay? Already the record has Reza as a name and the last name is Baseda. Okay? So when you read the query, read the page from the disk to the buffer, you see that the item is already in the correct state. Then you don't need to write it back. You are not wasting your time to write a page that is not changed at all. So a page, when after an update happens, a page that is required to be written because the state of the page is changed is called dirty. Okay? You call the page that is already changed and you have to rewrite it back to this dirty. Okay. So for the performance of the database management systems, there are a few parameters. One of the, as I told, the main factor in the performance of DBMS is accessing the time and latency accessing to the disk. So accessing to the disk has different factors and parameters over here. You can see the first factor is sync latency. So what does it mean? It means that it corresponds to the time you need to move the head back and forth. Okay. So my question: if you have a DBMS system, okay, when you install the DBMS, you allocate some specific part of the disk, and you allocate the whole set of cylinders. Okay, for example, a range of cylinders from track 20 to 25. Okay, so in this case, then the operating system is not managing the disk operations, right? It is managing the disk operations, but whatever you are supposed to write or read will be limited to this amount of tracks. So in this case, the sync latency will be decreased. Okay. So many database management systems, even Oracle, some of them asks you to decide if you want to allocate a specific area for that this management system. They have their own. Cylinders and tracks and range of tracks, and based on this dedication, because of this dedication, they have this speed above accessing the data. So in many cases, if you have large amount of data, it's recommended to follow this way of the installation of the DBMS management systems. For example, in the Linux servers, you know the Linux. When you are fragmenting a disk, okay, and you divide the disk to the drives or to the two sections, okay. These drives are based on the cylinders you are checking and you are creating, right? So many times, many of the I just remember that one of the DBMS systems, they ask you to have a non-allocated disk fragment, which is not used by the operating system, and then the DBMS wants to use that part of the disk freely and immediately can access its own data. So the other part of the other factor in the disk access I/O time is rotational latency. It's the time that you need to rotate the platters in order to make the header at the beginning of the sector you want to read. Okay, and the last factor of the latency and delay is transfer time. Transfer time is the time that you need to rotate the disk over the sector and read all of the items, okay? So this time is basically depending on the size of the sectors. If the sectors are larger, then this time will be larger.
Professor,
Yes.
In the seek latency, are we searching where we have to position, where we have to start?
What?
What do you mean by position the head over the cylinder?
Okay, so suppose that currently this is one of the disks. Suppose that we have other disks, other platters. Right? These are what? These are tracks. Okay. Now head is on this track. Okay. Head is on this track for all of this. Okay. Now we want to read the page, which is starting from this sector. Okay.
So we're searching for it.
So no, you don't search. There is something called a file allocation table, or there is something that, and also DBMS knows which pages, where the pages are located. Either the DBMS knows, or the operating system. So when the request is sent, then the head should be positioned on this track. So you should move the head toward this leg, and then you have to rotate the disk in order to make the start of the sector to the front of the disk. Okay, and then the time you need to try to rotate over the
Is rotation.
rotation. And basically, we call stick latency and rotation latency. Basically, we generally call the latency because transfer time is usually very small. And the goal of the operating DBMSs are minimizing this time. Okay. So one way to reduce the latency is if, for example, you want to read my record, okay? If you want to read my record and you want to read another professor's record, if all the records are in one page, then when you read the page that containing my record, then you load the page to the memory, and all of this accesses happens. Then for the next time, if the other professor's record is close to my record and it is kept in the same page, then you don't need to reload an access page. Okay, so this is the way that you are minimizing or reducing the number of disk accesses, and also therefore you are just reducing the latency. So okay, if you want to reduce now the number of the disk accesses, the first principle is put related data or the data probably requested access together, close together, to reduce the number. Okay. For example, if you have the record of students, and when you want to access record of students, you will access record of students of computer science and management, arts, and if you distribute all of the record of students on the disk, then you need, if you want to scan all of the computer science records, then you need to scan and access a lot of pages. But if they are close together, they can be easily accessed with minimum disk accesses. Another factor in reducing latency is the page size. Okay, if we have a larger page size, okay, then we are increasing the probability that two items are located in the same pages. Okay, because the size is larger and the probability is increased. But what is the disadvantage of this?
Disadvantage of what?
Disadvantage of increasing the size of the pages.
A lot of time.
Transfer time will increase
will
out
be-
of
Transfer time will increase, buffer
size
will increase, and when you are hitting a miss for the page, then when you miss the page and you need to transfer, you need to pay a lot of cost. So this is a trade-off between large page sizes and small page sizes, and usually put this size constant 4K. Okay, so the other way to reducing the number of the page accesses are using caches, and you need to keep the cache in the memory, and you cache some of the pages you already accessed, and you don't need also access, but you still keep it in the cache in order to future calls and future accesses. So for this purpose and for this mechanism, you need to decide when you need to purge a cache, because cache size is limited and you cannot fit all of the pages you read to the cache. And then you need to choose an algorithm to write back and to purge some of the cache, some of the pages back to the disk. Again, here, if you mark the clean and dirty pages, then you will save a lot of time. Why? When you are purging a page to the from cache to the disk, if you know that it's a dirty page,
We don't have to.
if it is a dirty page, you have to write it back. If it is not the dirty page, it's not changed, and you don't need to do anything, you just replace it, okay? So recording clean and dirty state of a page is helpful also here. This is the main organization and structure of the data access for the pages. For example, suppose that this is a blog and you have these page frames loaded to the memory, and some of them are cached and are not accessed currently by the DBMS, but they are still here. An application is requesting some record from this page. If the page is not existing in the memory, then the block will be transferred from the disk to the memory, and the request will be granted. Otherwise,
The size of cache is dependent upon the database management system or the hardware? Like
both of them. If you are rich people, you will have better computers and larger memories, and then the DBMS can get more cache. If you if the DBMS is not able to manage large caches, and then it cannot be, because this cache should be indexed, and also there should be a table to control all these caches.
So there is a certain threshold, like
Right.
after that, how much hardware we increase, the database cannot, the DBMS cannot handle the.
If in the old days, this was the limitation. I remember that DB2, for example, this has this limitation. You had to specify how much is the size of the cache, how much you dedicate the cache. Because if you can assign more caches to the DBMS or less caches. Whatever cache you are getting, if you are assigning a lot of cache to the DBMS, then you are decreasing the amount of cache for other applications. Maybe it's your preference to decrease the amount of the cache for the DBMS. So the DBMS is also externally maybe limited.
Professor, what is exactly cache? Like it's space in the disk?
The space in the memory.
Space in the.
The space in the memory.
So then we have one more cache like in the CPU, right?
Well, that's saved for processing and CPU purposes. And that's
It will not be any useful with this.
No, that cache is just a few megabytes, right? And it's used for CPU purposes to increase the computation speed.
So then we can have a lot of cache, right? We can able to lot of cache.
Yes, but if your data is very large, then that a lot of cache maybe, and you write a very bad query, and a lot of cache maybe, or you don't have an appropriate index, a lot of cache will be not sufficient. Again. So you see that there is a disk access on computers, on every laptop and desktop computer. The light is blinking, storage accesses. Okay, when you're running a query in the servers, you have seen racks of the servers, right? Have you been if you have seen racks of the servers? The racks of the servers, we will talk about RAID, but usually they have at least one storage, and if the query is running and the query is like, or it depends on the OLTP or OLAP query, a lot of access will be happening. You know, then the people administrating the racks can see what is the status. For example, if you go to Bank of America has a facility in New Jersey. I don't know how many people have been there, but if you go there and they have this, or CA Technologies has a facility, and it keeps information for, it gives services to these banks. They have their own cloud and their machine rooms. They check all of the storages, and if the storage access is not efficient for the database records, then they sometimes give an alert to the people, or they decide to change the disk organization and so on. Okay, so RAID. How many people know about RAID? Should I cover RAID or not? RAID. Have you studied RAID in the file structure course? Yeah, file structures. Okay, so we'll talk about RAID very fast. So RAID is basically the redundant array of independent disks. Basically, what we are doing is instead of using one disk, we are using multiple disks. Okay. So what we are doing is then, based on the techniques we are storing the information, we will have some flexibility, some reliability, and different factors will be changed. The first thing coming to our mind is that it's providing us higher throughput. Basically, different requests to different disks can be answered independently. So this can be working independently, and also a single request, if the data of the single request is distributed over different disks, then the read can be done in parallel, and you will see some speed up. Also, if you have redundancy on the data, then because you have different disks and you can replicate storage of data, then you will have more reliability. So, striping or stripping is the technique that we are using to divide data on different disks on the RAID. Basically, data is divided into chunks to be stored on different disks, and chunks can be bytes or disk blocks. It depends on the technique we are using. So if you don't have redundancy, for example, if you want to store the data on 3 disks, then the first chunk will be stored on the first, second on the second, third on the third, and fourth on the first, and so on. You know. Similar. For example, this is an example of storing data on different. Alright. Okay, so we can have different levels of RAID system. The first level is called level 1, which is basically okay, so in level 1 you are suppose that you have n disks, so and you have no redundancy. Then what you are doing is you are distributing your information based on the technique, based on the mechanism in the previous slide on different disks. So in this case, you don't have any reliability. If one failure happens, then the database cannot recover easily. In the level 2, you will have mirrored disks. So suppose that you have array of n mirrored disks, then all the way to suppose that n is equal to 2. Then it increases the reliability, because if one disk fails, the system can continue and still recover. it increases the speed of reads. Why?
Parallelism.
Because either one of the disks can answer your request. Doesn't matter, and those requests can be answered independently. Decrease the speed of write. Why? You should write twice. Okay. And also the price, the hardware is the required hardware is doubled. The level 3 disk. So level 3 RAID is using n disks to store n chunks of the data as we store in level 1. We distribute data on n disks, and the n plus 1 disk is used to store the XOR of the corresponding bytes on the other n disks. This n plus 1 disk is called parity disk, and and chunks should be here bytes. You have to distribute data based on bytes. So
What is the use of n plus 1 disk?
okay, the users here. Okay, redundancy increases reliability because so now suppose that you store information on n disk and you store one parity bit on the n plus 1. Okay, so if one of the disks fails and the data is damaged, then you can recover the data based on parity disk. Why? Because the missing data is always the XOR of the rest of the bytes. So,
But what if two of them
what?
gets damaged? So,
Bad luck.
It is correct.
yeah, because, I mean, if we, then we have to find out because
Yes, but the probability, if you compute the probability, will be very low.
we can only find out if one of them is damaged.
Right. And if you know it's damaged, you can cover it. If you don't know,
Yeah. I mean, if it's an error.
right. So, it's not efficient write-wise. Why? Because you always need to update the parity disk. So the parity disk is the bottleneck of your disk operations, write operations. And for each write operation, you need 4 disk accesses. One is reading disk access from the corresponding block on one of the n disks. The other one changing it and rewriting it back. The other one getting the parity and updating from the parity disk, and then updating the parity back to the parity disk. So it's very costly regarding to the write. So level 5 RAID is basically similar to level 3, but here the chunks are blocks, and the parity information is strict and stored on each disk. Okay, so it means that the parity is always sitting with you in the disk. Okay, and the parity is
So another disk is not required.
yes. So when you are updating something, then on the same page, on the same disk, or on the same page, you have this, on the same block, you have this parity, and you know how to update it and update it, and it will be faster. This is also usual for transaction processing applications. Why? So, you know the difference between database applications. One type of database applications are OLTP, online transaction processing, like bank accounts. When you are transacting, you're running transactions, a lot of updates will happen, and updates will be the unit of the updates will be very small. For example, one record, one balance, the balance of the account. The other type of the database, OLAP, which is analytical processing. You have to compute a lot of reports and you have to retrieve a lot of things. So if you have if your application is, if you are expecting a lot of read, okay? So if you are expecting a lot of it and the number of the writes are very small, then what you are doing is you are using this type of parity, this type of rate, level 3. If you are using OLTP, you need to use this type of the rate. Let me give you one question. So suppose that we have a system. I wrote a system for the dealership of a car manufacturing company, like for example for Toyota. So the company, the corporation wants to know the status, the aggregates of the number of the parts claimed and changed for each car in the guarantee period as a report. Okay. Also, each dealership, when they are changing some parts in a car, they submit a query. They have this application. They register what they are claiming online to the system. First of all, give me as a designer, how do you design this system?
The database?
The database.
Schema, you're asking schema?
The schema is not, no, the schema of the tables are not important. The physical schema.
Rate 3 is
Which one is good?
Rate 3. Level 3, rate level 3.
Because of the number of the transactions. Then what happens when you have a lot of read? You know, how can you make it more efficient?
Reads are done by level 3. But if we have more reads, we use it.
Level 3 is good for the
Reading.
reading,
That's what you said.
right? But for the parity check and also parity check,
Then level 5.
level 5. Okay. So what you are doing, I suggest you to have. This was a problem in one of the companies that I was working. So we had this claim information, and the company was not running very well. The cars were not good, so and they had a lot of claims. So the after-sales services were submitting these online transactions a lot, and we had this database. We needed this records on in the system to be shown to the management. So what the first solution is, okay, either choose, I want to have an OLTP or OLAP, okay, OLAP or OLTP, okay. So this is the this is not a good solution. Why? Because it's not satisfying either parts. It's not satisfying for after sales service dealerships, or it's not satisfying for management because it takes a long time to generate a report. What we did is we replicated data. We had this OLTP on the after sales services, and every night we have one write to management data. We have this delay of having 1 day delay for the correct answers for the management reports. Could be tolerated also, but we have this. We satisfied both of them. You know, the data was replicated. One was based on the OLAP, and the reports and the indexes were customized all for the OLAP, and the other one was for OLTP. You know, after sales services were working on their sides. Basically, the true story was they had their systems, and we wanted to develop a system for the management. And at first glance, we wanted to use their database, and we didn't have this power, or we were not authorized to change their database system. So what we did is we separated our database, and we had this daily or nightly updates, which was just one write. It was more efficient. Okay. This is also like level 10 is also
15 minutes.
combination of level 0 and level 1. So it's not practical.
15 minutes.
Twice many disks. So it is combining both of them. So the other part is the other important part of the RAID system is controller cache, which means that when you are reading from a disk, you can put some of the data on the cache of the disk. Okay, so what's the difference between cache of the disk and the cache in the memory? Cache on disk and cache in memory. The speed of the cache in memory is 0. The latency for the cache in memory is 0. But for the cache on disk, controller cache, you need to transfer all the data if you want to process to memory. So you are aware of the pyramids of memory, right? So this is the okay. So control cache is somewhere in between RAM and disk. It's faster than disks because when you are putting everything, when you are reading something from the disk and putting it on the cache, you don't need to do all of the seeking and rotating to reach the data, but it's stored on RAM because it's further to the CPU, and in order to process data, you have to bring everything from the cache of the disk to controller to RAM. So this type of cache is also used to increase the efficiency, and so when you are reading from the disk, if a larger number of the disk pages are read to the cache, then it will be easy to write to answer read queries. So you don't have any cost to
I don't know. Submit in time. Submit it in time.
you don't need to confess your mistakes, you know. If you have a mistake, and let's forget about this. Okay, so in this case, if you put the write for the disk for the read cache, the speed will be you will have a speed up because you do not need to rotate and do have all of these rotations. For the write, you also can have lazy write. You can write the when write happens, you can store some of the dirty data on the disk cache, controller cache, and then by some delays you can reflect those writes in the system. So, okay, now this mechanism is ending. Now we are talking about access path. So what is an access path to the database system? Basically, access path is referring to the algorithm we are trying to reach the data, and also data structures we use to keep the information. Okay, so the choice of the access path doesn't have any effect on the SQL statements. Semantics. Semantics is completely separated. Why? Because physical schema is separated from logical schema and also external schema. Okay, so and there is no effect from the choosing different types of algorithms and data structures for the DBMS on semantics of SQL. But choosing an appropriate access path is very important in the performance of a database system. So the first and the simplest type of the the simplest data structure we can keep the information in heap files. Basically, in the heap files, what you are doing is you have a file of the rows and entries, and whenever you add an entry, you add the entry at the end of the file. So the first disadvantage of this is you are wasting a lot of space if you are doing deleting, because the delete will remove some entry from the middle of the file, and that middle of the file will not be used. So one solution to this is what? Periodically,
Fragmentation.
the fragmentation in the operating system is the same thing over here.
Yeah.
You are periodically removing the free spaces and compacting the files. Okay, then you remove the shrink the size of the file. The other solution, easier solution, when you are appending or inserting, go to the file and search for the first empty space and put your record on the empty space.
But fragmentation is better.
Fragmentation is required because in the second case, even in the second case, you may have a lot of free spaces left. After a long time, your file will be very large. Okay. Also, the fragmentation many times you are sorting those stuff services. They are not considered. Okay, for example, here you can see some examples when suppose that we have different pages storing the information for this registration of the classes by the students. So when you are reading some information, there will be some gap. So, okay, now let's consider the performance of heap files. Okay, so for inserting a record to the heap file to the database, what is the cost? Access point is a scanning. Data structure is heap. What is the cost for the inserting? Average cost is F divided by 2. Why? Because you have to scan and see if the record is already existing or not. If the record is existing, you are not doing anything. So the insertion requires to check if the record is existing or not, because you are not adding an existing record in order to avoid duplicates. Okay, so and the average time for the search is F divided by 2. Why? Because
Because we'll go to the hub.
We can get it in the first place 0 or get it in the last place.
Omega of,
Average will be affected.
yes, it's omega of a linear search, right? So and the worst case is
F plus 1.
F plus 1, because you go to the end of the file and then at the end you have to add it. Deleting a row. The average is F divided by 2 plus 1, because you have to search for it, find it, and then you find it 1 to remove it. The worst case is F because you don't find the code at all.
Isn't it F plus 1?
What?
Isn't it F plus 1?
We don't know.
No, if you don't find it, then you don't do anything. You go through F number of pages and you don't find the record. What you are doing is for the query. Okay. If the query is returning all of the rows without any sorting, it's very efficient. Just go and retrieve data and return it. If you are supposed to either sort it or return a specific row, small number of rows based on the convert clause, then the average time will be F divided by 2. Okay? Or if the search is happening for a range, again, the average time will be F2 multiplied to,
For search,
no, F for the range,
for range,
yes.
it will be F.
The average time is?
For everything will be F plus 1. 3. Check.
No. Theta of, suppose that you have this omega of n2, okay? Omega of n2 plus omega of n2 plus omega of n2 is blah blah blah, is omega of n2. So here is, we have average time f divided by 2, and the average time will be f divided by 2 again, because what you are doing is you are scanning all of the records and returning the records fitting in the range.
So then F by 4 you're saying?
Sorry, it should be f. Right?
That's
That's
what I
what
said,
should be
plus
F.
one.
Sorry,
F by 2 plus F by 2 will be F.
So why is it f?
So F by
So
2
half
will
again, F by 2 for 1. Add them up. So
Because
1 will take.
cannot say why.
No, for range it has to be F, right?
Why?
Because you take the full length. You're taking the full length.
And
You're
the
taking
condition
the
should be
range
should be
from
satisfied.
starting to the last point. You're taking the whole thing.
Right.
That has to be F.
For the single row, the condition was whenever we see the
Yeah,
condition,
sure.
we return the row. Since the return is one row, is f divided by 2, because as soon as we see the record, we stop searching, and the probability of this single record is f divided by 2. Okay. For the range queries, it's f, because you have to either scan it to the end to check if any records is left for the matching the range. So the second type of data extraction is sorted files. Basically, rows are sorted by according to some attributes. Basically, access path is binary search. Then every retrieval based on the search key is log f2. Okay, log of f to the base of 2, and okay, so the other advantage is
Successive with 2 final together.
if you are looking for similar records, okay, based on the search key, the probability that those records are staying in the same page is very high, because it's sorted based on that those. Then the number of the page size, the page retrieval will be
Degree.
the number of the decrease, and the probability of hitting a cache is increasing. So
So log to the F, log to the base 2 for F is for this sorted fashion.
right. So I want to stop over here. Right, we have 5 minutes more, and give you a simple, fresh, tiny query. Consider the employees database. I know you love this database. You don't need to write this query in your computer, you just need to write it on a piece of paper. Just when I am checking the attendance, you'll say if you are done with this or not. You have 2 minutes to write this query.
I'll go to that page.
Return all of the name of the departments, the name of the departments, the name of the departments that have a lady as a manager today.
Today?
Today.
Today, what is the date?